Right now, as you sit there reading this, you are moving, not walking, not driving. You are spinning through space at over 1,000 miles per hour, faster than a bullet fired from a rifle. You don't feel it. You never have. Your entire life, every heartbeat, every sunrise, every sunset, all of it has happened while the ground beneath you screamed silently through the void. Now imagine that speed, vanishing, not slowing down, not easing, stopping, instantly. In the next 90 seconds, everything you know about morning and night, gravity and wind, oceans and cities, would cease to exist as you understand it. This is what would happen if Earth suddenly stopped spinning. Let's be precise about what instantly really means, because the universe does not forgive shortcuts. Every object on Earth's surface is moving with the planet's rotation. At the equator, that's about 1,040 miles per hour. If the planet stopped, but everything on it kept moving at that speed, the result wouldn't just be catastrophic. It would be apocalyptic, in the most literal sense of the word. The atmosphere itself would keep moving. Air, which was traveling at rotational speed a moment ago, would now slam across the frozen, motionless ground like a hurricane 1,000 times stronger than anything ever recorded. Winds strong enough to flatten mountains would rip across continents. Buildings wouldn't just collapse, they would be sandblasted into dust. The oceans would behave the same way. Water, still carrying that immense rotational momentum, would surge forward in walls taller than skyscrapers, scouring entire coastlines and sweeping inland for hundreds of miles. Every coastal city on Earth, from Tokyo to New York to Mumbai, would be erased within minutes. And that's before we even talk about the people. Every human being, every animal, every loose object not bolted to bedrock would be hurled eastward at over 1,000 miles per hour. The laws of physics don't care about mercy. Momentum doesn't stop just because the ground did. Here's the good news, and it matters, so let's pause on it. Earth's rotation carries an almost incomprehensible amount of energy. Angular momentum built up over 4.5 billion years of formation and collision. To stop that motion instantly would require a force so massive, so absurd, that nothing in our solar system could realistically deliver it. Not an asteroid, not a comet, nothing we've ever observed. Scientists who study this scenario treat it the way a stunt coordinator treats an explosion, not as something that could happen, but as a way to explore what physics actually demands of our world. It's a thought experiment, a lens, a way of making the invisible, forgotten motion beneath our feet suddenly, terrifyingly visible. So let's set aside the instant version and ask the more interesting question, the one scientists actually find worth exploring. What if Earth's spin didn't stop in a second, but slowed down gradually over months or years or centuries, winding down like a fairground ride, finally losing power? This version isn't just survivable to imagine, it's fascinating. Picture it happening over the course of a year, almost imperceptible at first, a few extra minutes added to each day. Nobody would notice until they did. The first sign would be the weather. Earth's rotation is the engine behind the Coriolis effect, the invisible hand that curves hurricanes, steers jet streams, and organizes our entire climate system into the predictable bands we've built civilization around. As the spin slowed, that hand would loosen its grip. Storm patterns would drift. Trade winds would falter. Monsoons, the lifeblood of billions of farmers across Asia and Africa, would arrive late, or not at all. Agriculture, so finely tuned to seasonal rhythms, would begin to fail in places it never had before. Then comes the light, or rather, the absence of it. As rotation slowed further, days would stretch, not by minutes, but by hours, then by days themselves. Eventually, if the planet stopped completely, one full day would equal one full year, the time it takes Earth to circle the sun, Half the planet would face the sun in an endless, blistering day. The other half would face away, locked in permanent, freezing night. Imagine standing in Kansas as the sun simply stays, refuses to set, day after day, week after week. Temperatures on the sunlit hemisphere would soar past anything in recorded history, potentially over 150 degrees Fahrenheit in some regions, hot enough to make outdoor survival nearly impossible. Meanwhile, on the dark side of the planet, temperatures would plunge to levels that could freeze carbon dioxide out of the air. Two Earths, one scorched, one frozen, sharing a single, motionless planet. Here's something almost nobody thinks about. Earth isn't actually a perfect sphere. It's a bit like a ball that's been gently squeezed, flatter at the poles and bulging outward at the equator. That bulge exists because of rotation. Spinning creates outward force, and over billions of years, that force has physically molded the shape of our planet. Take away the spin, and that force disappears too. Slowly, gravity would begin reshaping Earth into a more perfect sphere. The equatorial bulge, nearly 13 miles of extra girth, would gradually sink inward. And where would all that material go? It would have nowhere to go but toward the poles and into the oceans, triggering colossal shifts in sea level. Entire regions near the equator, once safely inland, could find themselves swallowed by rising water, while other coastlines might emerge as the seas redistribute themselves across a reshaped globe. The map of the world as we know it, every coastline, every island chain, every familiar outline you learned in a classroom, would slowly dissolve and redraw itself. There's one more consequence, quieter than the winds, quieter than the flooding, but arguably more dangerous than all of them combined. Deep beneath our feet, Earth's molten outer core churns and swirls, and that churning motion, driven in part by the planet's rotation, generates our magnetic field. That field is invisible, silent, and utterly essential. It's the shield that deflects the solar wind, the storm of charged particles constantly blasting off the sun. If Earth's rotation stopped, the dynamo effect powering that magnetic field would weaken dramatically over time. And without a strong magnetic field, our atmosphere itself would be vulnerable, slowly stripped away by solar radiation, the same fate scientists believe befell Mars billions of years ago, transforming it from a once wetter world into the dry, thin-aired desert we see today. Humanity wouldn't just be dealing with floods and endless days. We would be watching, over centuries, the slow erosion of the very air we breathe. And yet, life is stubborn. If this change unfolded gradually enough, across generations rather than seconds, human ingenuity might find a way to adapt. Cities could migrate toward the narrow, livable twilight zone, the thin ring of the planet caught permanently between blazing day and freezing night, where temperatures might hover in a survivable range. Engineers might design massive sun shields or underground habitats. Agriculture might move indoors, powered by artificial light on carefully engineered cycles. It wouldn't be the world we know. It would be a world of refugees fleeing toward a twilight belt, of societies rebuilding around a sun that never moves, of humanity learning to live on a planet that finally, after 4.5 billion years, went still. So the next time you watch a sunset, that slow, golden slide of light below the horizon, remember what's actually happening. The sun isn't moving. You are. The earth beneath your feet is carrying you, right now, at over 1,000 miles per hour, spinning through the dark with a silence so complete, you'll never hear it, never feel it, never notice it, until, perhaps, the day it stopped.